All right, let's do one more problem here. This time we have a little bit more hard problem because we have two different radicals here. We have a square root here and we have a fourth root here. So again, you could write this if you wanted. You could write this as the square root of x plus 5 minus, this is the fourth root of 5 minus 2x equals 0. Right? These are equivalent. You could write it like this, but I'll stick with the rational exponents. Okay, so again, our key idea is we want to isolate the root, but this time we've got two different roots. Then we're going to raise both sides of reciprocal power, but we have to do something a little bit different because, again, we have two different exponents going on here. So this time, rather than isolating, because, I mean, we can't just get one of them by itself, we got to kind of deal with them together. So let's move this one over to the other side. We're going to add 5 minus 2x to the 1/4 to both sides. 5 minus 2x to the 1/4, which is again the fourth root. So we're going to get x plus 5 to the 1/2 equals 5 minus 2x to the 1/4. Okay? So they're just kind of on both sides there. Now we have to think carefully. We want to raise both sides to the reciprocal power, but let's think about this. If I square both sides, actually let's just go ahead and try that. If I square both sides, second power, you could try that. You're going to get 2 over 2 here, which is great. We like that. That becomes a 1. But over here, you're going to get 2 over 4. So it's still going to be a fraction, which we do not want. So rather than raising both sides to second power, let's raise both sides to a number that's going to knock out both the 2 and the 4. Right? So you can think of like the LCM of 2 and 4. That's just 4. So rather than raising both sides to the second power, raise both sides to the fourth power. And then we will see we have 4, we multiply these 4 over 2. So x plus 5 to the 4 over 2, which is going to be 2, equals 5 minus 2x. So that's 1/4 times 4. So that's going to be 4 over 4. And now we can see both of these are going to simplify to something we are a little more comfortable with. So x plus 5, 4 over 2 is squared, equals 5 minus 2x to the first power. All right. Again, though, how do we solve this? Well, we can look, okay, it looks like we're going to have some kind of quadratic equation here. So why don't we go ahead and multiply this out? So x plus 5 squared. So x plus 5 equals, we'll drop the parenthesis. Let's go ahead and FOIL this out. So x times x is x squared. Outside 5x, inside 5x. So 5x plus 5x is going to give us 10x. Right? You can FOIL that out just to check. And then 5 times 5 is 25. Okay, so we can see it is indeed a quadratic equation, so I could solve this by factoring or quadratic formula. But let's go ahead and try factoring. So let's get 0 on one side. Again, we want this quadratic term to be positive, so let's move the other guys over here. We'll subtract 5. So we get x squared plus 10x plus 20 equals negative 2x. And then lastly, let's get this guy over there, so we'll add 2x to both sides. Add 2x. So we get x squared plus 12x plus 20 equals 0. All right, that might factor. So again, let's go ahead and draw this guy. A times c, so 1 times 20 is 20. B is 12. The two numbers that multiply by 20 add up to 12. You can pause it and check if you want, but that's going to be 10 and 2. Now, because a is 1, we can just be done with this. We don't have to rewrite it, split it, do all that stuff. We just get x plus 10, x plus 2 equals 0. 0 product property, so x plus 10 equals 0, or x plus 2 equals 0. So therefore, x equals negative 10, or x equals negative 2. All right, last thing, negative 10, negative 2. Let's see which one of these maybe work and which ones are extraneous. Let's try negative 2. Let's try negative 10 first. Let's do negative 10. Let's plug in negative 10 right here. So negative 10 plus 5 to the 1/2. Does that equal 5 minus 2 times negative 10 to the 1/4? So just plugging in negative 10. And right away, I think I'm starting to see a problem. Negative 10 plus 5 is negative 5. Negative 5 to the 1/2. We could just stop right here. This means a square root. You cannot take the square of a negative number. That's not going to be real. That's going to be an imaginary number, and we're not dealing with that. So right away we know, because we've got a square root of a negative here, negative 10 is not part of our solution set. So negative 10 is extraneous. All right, let's go ahead and try negative 2. Let's try negative 2. So let's plug in negative 2 instead. So negative 2, all right, plug in right here. Negative 2 plus 5 to the 1/2, square root, in other words, minus 5 minus 2 times negative 2 to the 1/4. Does that equal 0? And I realize I did the other one here, but that's okay. So we're going to get negative 2 plus 5, that's 3 to the 1/2 minus, so what's this? Let's see, 5 times negative 2 times negative 2, that's a 4. So 5 plus 4, 5 plus 4. So that's going to be 9 to the 1/4. Does that equal 0? It looks like no, but let's see here. 3 to the 1/2. I could write that as the square root of 3 if that helps see things a little better. Minus 9 to the 1/4. I don't know what this is. Let me try and make this as a base 3 instead of 9. So let me rewrite 9 as 3 squared. 3 squared, right? That's the same thing as this. All to the 1/4. All to the 1/4. Now I have a power to a power. 2 times 1/4. So I have square root of 3 minus 2 times 1/4. That's 3 to the 2/4. But 2 over 4 is just 1/2. So we have square root of 3 minus 3 to the 1/2. Does that equal 0? Remember, 1/2 just means square root. So square root of 3 minus square root of 3, does that equal 0? Yes, indeed, it does. So negative 2 is the solution, and negative 10 is extraneous.